In home server and home lab communities, it's typically recommended to use software RAID these days to manage multiple disks into one large array with redundancy. But in this video, I want to take a closer look at hardware RAID solutions, how they work, and how they compare to a few software RAID solutions, in applications like how easy it is to management, hardware used, CPU usage during I/O-heavy tasks, performance in different use cases, and rebuild times. So get ready for some interesting information about RAID arrays and different ways of setting that up. Starting off with a comparison of these different solutions, I want to go with what I generally consider to be hardware RAID and software RAID and some general overviews. This is kind of what I consider to be a more traditional hardware RAID solution, a Dell H710P. This card has a chipset that manages all the RAID calculations, so the CPU on the system doesn't have to do anything. It has a gig of memory on it, so that way all the operations can be cached, and things that are being written to the array can be stored in that memory safely until it gets stored on disk. And to ensure the memory is safe, there's a battery on board that can keep the RAM going even if the system were to lose power, and continue in-flight write operations when the system was turned back on. Software RAID solutions, on the other hand, have all the different disks visible to the OS, and then they basically take data and spread it across the different disks. I'm going to be taking a closer look at ZFS and MDADM, as they are Linux solutions that kind of are the most equivalent to a hardware RAID card, but BTRFS, storage spaces on Windows, Unraid, and many others can have different compromises and all work to achieve the same goal of having multiple disks appear as one big volume with some way of setting up redundancy. Now, when it comes to the pros and cons of hardware RAID versus the software RAID solutions, the first thing is hardware used. Hardware RAID cards require a piece of hardware to store it on, which typically isn't included in most, especially consumer-grade systems, at an additional cost. You're going to need a PCIe X8 slot for the system to go in, and you have to plug all your drives into the hardware RAID controller. And if it's using a battery like this one here, these batteries only last so long, so you have to make sure you replace them every once in a while so that that operation of the disk and your write performance isn't going to be affected. I'll have a little bit more data on how this affects write performance later on in the video. When it comes to software RAID, it's a lot less picky hardware-wise. Essentially, as long as the drives plug into the system, it can be used in a software RAID solution, but some software can be a little picky. So I could have half the drives plugged into maybe even this card as an HBA, and the other half plugged into onboard SATA. Or I could have some via USB or even iSCSI drives, although that's not recommended typically. But it will just work as an array as it sees it as an internal block device. The flexibility of software RAID continues if I want to be able to reuse these drives on another system, as if I take these drives and just plug them into a new host with the applicable software installed, it should be able to detect that array and continue using it. Whereas if this hardware RAID card dies, or I want to use these drives in a new system that was set up in hardware RAID, I typically need another model of RAID controller with the applicable features from the same manufacturer. On the other hand, one big advantage that hardware RAID offers is it just gives your OS a single drive to access like a single disk typically would. And the biggest advantage I see is if you're using an OS that doesn't support having a bootable RAID Windows, and you want to set up something like mirrored or striped boot drives. Linux, on the other hand, handles this generally pretty well. Or if you want to make it so you can dual boot a system between Windows and Linux and access the same volume, as most software RAID solutions only work on one OS, like Linux or Windows or BSD variants, and don't easily import on different OSs. When it comes to managing the RAID array, setting up the RAID array, viewing its status, and everything else, hardware RAID cards typically give you an option to have a pre-boot environment where you can see what's going on with the controller, set up arrays, delete arrays, or change other things. The thing I've noticed is those pre-boot arrays can be kind of picky. They work fine on server boards like the dual Opteron one I did all my testing for the video on, but this consumer grade i9-12900K didn't seem to work. And I've had a general experience that a lot of gaming or consumer grade boards won't work with a couple of RAID cards I've tried in the past, but server boards typically work just fine. Pre-boot environment doesn't work. It generally can be managed within the OS, and there's utilities available for most RAID cards within major OSs like Linux and Windows. The disadvantage with those utilities are they're typically not updated that much once these cards go end of life. So while the utility might work just fine for this card on Debian 12, for example, Debian 18 support in the future is kind of a bit iffy. But I'd guess that MDADM and ZFS will work just fine in Debian 12 when it eventually comes out, as those keep getting updated and your drives can keep getting updated with it. Software RAID typically has its own utilities to management within the OS, often those command line utilities and options for GUI utilities within the OS or web GUIs. All of these solutions can be set up to set up notifications to bug you if a drive has failed or the array has different issues. And while all of these management systems are a little bit different, I think once you get used to it, it's typically easy enough to set up the RAID array, add a disk perhaps, see if there's different issues, or work with it. I think the biggest caveat is if you get used to one solution and then switch, all the buttons and terminology might be different, so it can take a little bit of getting used to different possible solutions. Now let's take a look at the performance, rebuild times, and CPU usage of these different solutions. My test setup involved having 8 4TB WD RAID Plus hard drives set up in a RAID 6 array, which should be a worst case when it comes to CPU usage as well as compute power needed for the RAID card. I then made a test file using FIO in Debian 12 to fill it about 2/3 of the way full to make sure I kind of simulated a maybe average use case for amount of space used on these drives. For my system I used an old dual Opteron system I had laying around with 12 gigs of RAM. While these CPUs are definitely pretty slow, it should represent kind of a worst case scenario when it comes to CPU usage percentages, as most CPUs you're using now are likely going to be faster than this old system. Taking a look at my sequential read performance, the first thing I notice is that the hardware RAID card is kind of the best here in terms of reads and writes and nearly maxes out the theoretical performance RAID 6 should give me on these drives. ZFS isn't that far behind. MDADM looks kind of slow. I'm going to talk about this in a second. And then I included a single hard drive connected to this card in JBOD mode for some of the tests and connected to the onboard SATA as well. The thing I noticed was MDADM just seems pretty slow here, especially in writes. So I tried tuning it and using other tips online I saw to improve performance, like changing the striped cache size, and none of that seemed to help very much. I turned FIO from direct mode on to off, which allows it to use the RAM to cache a bit more, and I got a bit higher write speeds, but still under the speeds I would expect as a maximum. What I'm kind of guessing is going on here, but I don't have a great way to confirm it, is this involves how MDADM handles the write hole problem in RAID. So let's actually talk about the RAID write hole and how it affects these solutions differently. When doing a RAID operation on multiple drives, one possible issue is that some of the drives have the data written before other drives and they're in an inconsistent state if power was to be lost at that very second. This is typically the worst at something like RAID 5 or RAID 6, because if I want to write only a little bit of data, for example, maybe it only is 2 drives worth of data, I now have to read the other 4 drives worth of data and compute the parity and write it to the other ones, to the last 2 parity drives. And that can take a good amount of time on a larger RAID array with slower disks. Hardware RAID cards solve this by just keeping track of write operations in their built-in cache, and since there's a battery to keep it safe, they can be sure that that data is going to be written safely to disk. And that's why, as we'll see in a little bit, write operations slow down significantly when I get rid of the battery cache on this system, because it can't safely use its onboard memory anymore. ZFS solves this problem a little bit differently by only writing data and never updating data. So for example, if one stripe of data needed to be changed, ZFS wouldn't change that. It would effectively use its copy on write to write 2 new data chunks and 2 new parity chunks and just say, that's where it is now, and I'm never modifying the old data. On the other hand, MDADM uses a journal, like many journaling file systems, to keep track of its different write operations, so it can work back in time if it was to lose power and figure out what's going on. That's kind of like how the RAID card uses its internal memory as a journal, but instead of having essentially an extremely fast journal that's safe on here, it has to use the slow disks. And I'm guessing because these disks don't handle many IOPS, because they have to write both the data and the journal, its performance goes down significantly. But I didn't have any other clues or good ideas, and while it feels like MDADM should be able to do faster, none of the tuning or configuration I could find would affect my RAID array's performance. Switching over to random I/O, I can see that turning off the direct mode on my MDADM writes causes that performance to go just way up, as it's effectively using system RAM as a way of storing data in flight and being able to write it to disk much faster. The graph is a lot easier to read once we get rid of the MDADM that can write it super quickly. And what I notice is hardware RAID card is generally the best, and if you're doing write-heavy operations, make sure to have that battery to get the best out of its write-back caching modes. And ZFS and MDADM are a bit slower than the hardware RAID card in all of my testing, but not hugely slow, especially if you're using mechanical hard drives, which are going to be relatively slow anyways, and probably shouldn't be used for heavy random I/O operations. Taking a look at CPU usage during RAID rebuilds and other operations, this hardware RAID card really just runs away with the win, as it has much lower CPU usage in its kind of CPU load in Linux compared to the other solutions. This seemed almost abnormally low to me, so I was looking at things like user and system percentages, and it still seemed to add up. One interesting thing I did notice is that when I had a drive plugged into my RAID card in HBA mode, it had a much lower usage than if my drive was plugged into my onboard SATA controller on the dual Opteron system. Perhaps there was some interesting issue with how that system uses its controller or overhead, but all of my ZFS and MDADM testing were using this as the controller. One other thought I had was possibly how the system reports I/O weight on having multiple disks versus one disk, and the I/O weight's kind of handled internally here might cause it to see higher load, but I'm generally going to live with my normal assumption in what I see online, which is while softer RAID may use a bit more CPU usage, when using mechanical hard drives, it's likely a non-issue. Even on my very old Opteron with its very slow cores, I was maybe using one core maxing out random I/O on these. When it came to rebuild times, ZFS was the winner here. One of the reasons ZFS was likely able to win is ZFS only rebuilds data that is data versus having to rebuild everything, because a RAID card doesn't know which part of the array is data versus which part is unused space. And ZFS knows that that's unused space, so there's no reason to copy that to the newly replaced disk. The RAID card was a good amount faster than MDADM in Linux, with MDADM showing the worst performance out of the bunch. In conclusion, I got a lot of interesting data after running these tests for about a week, and I hope this gave you some insights into how different RAID arrays might work on your different hardware. I still agree with the general recommendation that I think for a lot of home users, the increased flexibility and not having to require a specific card for hardware RAID is best for most users. But for example, if you're buying an old rack server that comes with one of these cards, I don't see any problem with using it if it comes with it, and it can definitely provide the best possible performance and save you a few CPU cycles. But the CPU cycles saved while I measured it was not that much CPU usage, so I don't think it's gonna matter that much, especially since most home servers and virtualization servers I've seen are under pretty low CPU usage on average. One other thing I like with many of these newer solutions like ZFS is it provides more of a all-in-one solution, where with ZFS I can do RAID, snapshotting, volume management, and more, but with a hardware RAID card I'll have to use its utilities to manage the actual RAID setup, maybe use something like LVM if I want a volume manager and snapshots, and then a separate file system on top of it, which is definitely a different process and different getting used to. I do also want to note with all these solutions, they often have a different best possible implementations. So if you have a RAID setup and want to move it to a different solution, don't just try to replicate the exact setup. You might want to look into what works best with that possible setup and how you should set it up to take best performance out of it. Hopefully this video was interesting to you and showed you a little bit about different RAID setups and their pros and cons. Let me know in the comments below what RAID setup you're using and how it's working out for you. Also, I've been trying to set up memberships on my channel to see if people are interested. I've made a few kind of behind the scenes videos of me working on computer stuff that isn't exciting enough in my opinion to make a full video out, and I'll do a little bit of early releases for some videos like this. Let me know in the comments below if that's something that seems exciting or changes you'd like to see me make.